Hello everyone, welcome to this module. In this module, we will design the foundation for this building which we have designed previously in ETAP. So before going to this design of foundation, let us extract some data which are required as an input in the SAP software. Okay, so what are those? So those are the reactions or the loads which will be acting at this 0 level or story 1 level. Okay, and the dimensions of the columns which will be supported by the footing. Okay, so for that we can go to this model. Okay, this should be done after this analysis and design. So let then we should go to this model and then structural objects, and then we are focusing on this story one. Okay, so go to this story one and then go to this column. So you can see the column if you double click on these options. Okay, so you can see the dimensions, right? And you can see, double click on any options, then you can see the dimensions of the column. Okay, now these are the columns which are placed automatically by this ETAP software, because we have used this automatic command for selecting the column and beam member. So these columns are selected. Now this name of the column is C4 C8 like this, so these are randomly chosen based on the analysis. Now we have to prepare the footing or foundation design in such a way that C4 column will be placed here, C8 will be placed here, like that. So now how can we know the name of this column? So for that you can go to this set display option, then go to this other object, then go to this label, click on this label. Okay, then click on apply, then you can see the name of the column. Okay, so likewise you can do it, and uh, you can make a rough of these dimensions or of the columns from these tables, from these menus, and also the location of the columns. And then last thing which is required, that is the dead load and live load which will be acting on that level. So for that, go to this table, then analysis results, then element output, then frame output, then element force, column force. So right click on this, click on this show tables. So you will see a table here. Okay, so here we have to go to this story one. So right click on this, go to story one. Okay, then we need the dead load first. So click on dead load, click outside. Then these are not required, so make it small. Okay, then we need the location that is at 0 level, so click on short ascending, so you can see the 0 level only. So here you can see the 16 columns are there, because at any floor there are 16 columns. So these C1 to C16, these columns are given here, and the dead loads are given because we have selected this dead load. So dead loads, these are the dead loads. And now we need so we have to keep a note on of this dead load and these all values. Okay, because this will be used as a input. So now next click on this live load. So these are the live load which are required in the SAP software. So keep a note of this live load up to 16 columns, C16. Okay, then we will use this data in the SAP software. So close this. Now another thing is required, that is the dimensions is 6 plus 6 plus 6, so 18 by 18. So whatever we provide the footing, that will be of higher dimensions, that may be around 21 meter by 21 meter or 22 meter by 22 meter. Okay, so now, so based on this data, let us go to this SAP software to design this foundation. So this will be the dimensions of this plan, building plan. And next, so these are the locations of these columns, C1 C2 C3 C4, like that. And here we will use the same bearing capacity of 300 kilonewton per meter square and allowable settlement of 1 centimeter. Okay, now we have shortlisted these. So the dimensions of the columns are these, and the dead loads and live loads are these, and the material of the column, okay, these are M40 HOSD 500. Okay, so there are 16 columns, so these are the other values. Okay, so this will be used. Then subgrade modulus, which is required to model the soil, that is SBC, say bearing capacity by allowable settlement, that is 300 by 1 centimeter. So convert it into meter, so that will be 3 into 20 over 4 kilonewton per meter cube. Okay, then column strip width, that is equal to 0.25 of L1 or 0.25 of L2, whichever is less. So that is L1 and L2 both are 18 meters, so strip width is equal to 0.25 into 18 meters, so it is 4.5 meters. So we can select a lower values also, that may be 4 meter. Okay, now we can design the footing, that will be somewhat higher values of these plan area, that will be 22 meter by 22 meters, so in our case. Okay, now let us go to the SAP software. So after opening this SAP software, go to this file option, then new model. Okay, then select the relevant code, that is IS456, then change these design preferences. So change this cover, so this cover are basically by default it is 15, so you have to change it to 50. Okay, then let us choose a bar diameter of 22 millimeter as suggested by this Skyfi Labs. Okay, then click on OK. Then check the unit, that is in metric units, so we don't have to worry about these units, so this should be in metric. Now then we should select this grid option, because automatically we have to we will not get the dimensions of 18 by 18 millimeter meter of mat slab, so you have to create that. Okay, so click on this grid option, then our dimension is 18 into 18 18 into 18 meter, so we have to number of choose the number of grid lines, that is 19 meter, sorry 19 numbers, it is 19 numbers. Then the dimensions or spacing of the grid will be 1 meter, so you will get the 18 by 18 mat slab. Okay, click on OK. So the grids are created. Now the first option is first thing which should be done here, it is to define the material. So go to this define, then material, then click on add new material, then click on M40. Okay, M40, then click the material type, that is concrete. Here choose the weight of this material 25, and here choose the modulus of elasticity, that is 31622.7. okay, it is 0.2, and here it is 0. This triple zero, then 0055 this, and the grade of concrete is 40, so click 40, so click on OK. So next is you have to use the HYSD 500, so add that material. So next is we have to define the slab properties based on these materials, so click on add new material, so click mat foundation, mat footing. Okay, this material will be M40 grade. Now this can be mat, and this may be 500 millimeter initially, so click on OK. Click on OK. Now we have to define the column properties. Okay, now see here material has been defined, slab has been defined, then column should be defined, because we have to use two type of column here in this model. So let us define this, so click add new property. So first column is 500 by 500 into 500, so select the material, so HYSD 500, then it is 500 by, okay, 500 by 500, then click on OK. Then another material, another column, that is 600 by 600, so 600 into 600, so this M40, no sorry, it is HYSD 500, so this is 600. Okay, click on OK. Click on OK. Now next thing is to define the soil subgrade properties. So click on the, if you can modify this soil 1, which is already provided by default. So modify this. So in our case it is 3 to 10 power 4, so it change this value. Okay, so this should be in compression. Click on OK. Click on OK. Then we have to go to these define, then load patterns, load case, and load combinations. Okay, other things has been defined. So click on this load pattern first. So it is all okay. So click on OK. Then go to these load cases. So here it is linear static as it is typed by this Skyfi Labs. So we have to go for this linear static method. So click on OK. Now go to this define, then load cases. So sorry, load cases has been checked. So then load combinations. So here you have to add new load combinations. So click on add new load combinations, which is 1.5. Okay, 5 dead, and this for live load it is also 1.5. Okay, click on strength, click on OK. Then another combination, so it will be dead load will be 1 and live load will be, sorry, this is live load. Okay, it will be 1. Then this service, service, and service. Click on OK. Click on OK. Fine. Now we have to define or we have to draw the footing. Okay, so go to this draw option, then draw slabs and areas. So select this slab, mat footing. Okay, that is all right. So click on this grid point. Okay, sorry, this. Click on escape. Now as we have said in the previous in the beginning, that is the footing dimension will be 22 meter by 22 meters. So we have to expand these footing dimensions as it is 18 meter by 18 meter. So we have to select this footing. Okay, to expand. So click in the interior portion of the footing. So you can select see the selection, one areas, 4 edges selected. So then go to this edit option, then edit areas, then expand. Okay, so you can type enter the offset, that is we have to increase by 3 meter. Okay, so because our dimension will be 22 meter, so sorry 4 meter, so in that case 4000 millimeter. Okay, so click on OK. So you can see here the dimensions have been increased, but here we have made a mistake because this in this side it is 4 meter, in this side 4 meter, so it has increased by 8 meter, so we don't want that na. So that's why let us undo that. So control Z, then again select this footing, one areas, 4 edges, then go to this edit areas, expand, then 2 meter. Okay, now it is okay. So we have increased the dimensions of this footing. So next is we have to draw the column. You have to place the column in the required location. So go to this draw and draw columns. Then we have to place this column. So you can take the reference which was shown in the beginning. So that is column 500 500. That is first column. Then property above is none. Sorry, property above is this. Okay, property below is nothing, none. Then height below this 0. Height above is 2 meter. Then okay, so now we have to provide the location. So you can see, so this is the first location. Click on left click on this option, then at 6 meter distance, so there will be another column. Okay, another 6 meter. Okay, then another 6 meter here. Now we have to place a column here at 6 meter, and here another one, then here 6 meter, like this. Now click on okay, click on here. So next is 600. So rest will be same. So now you can provide these columns here, 6 meter, 6 meter, then it is 6 meter, and here it is 6 meter. So these are the placing of this column. Okay, click on the close. So now we have to draw the what column strip. So go to this draw option, then this draw these design strips. Okay, so first is design strip is A. So the start with left will be 4 meter as said earlier. Okay, so carefully choose the line. Okay, right click, right click, right click. You can see the pink color is made due to this. Okay, then select the strip B. Okay, then right click, left click, left click, right click, like that. Finish all those. So now we have drawn these column strips. Now we can check these column strips. Okay, so go to these display options. Set display options. Then you can go to this design strip objects. Okay, select all these three options. Click on OK. So you can see we have successfully made these column strips for each directions. Okay, now we have to again this turn off this view. Click on OK. Okay, now next thing is that we have to define the property of these column strips. So next is, so we have to define the property for the column strips and the footing. So right click on this footing first, then click on this design, change this material as HOSD, click on OK, click on OK. Similarly, click on the every column strips. Okay, so here select the grade of steel, that is HOSD. Likewise, finish all the properties. Okay, so we have selected this. So let us select this one. Then we have to define the property of the soil beneath that footing. So what should we do? We should select this footing. Okay, so you can see the selection on the areas, 4 edges selected. So go to this assign, then support data, then soil properties. So soil 1 we have to assign beneath that footing. So click on soil 1 and then OK. So you can see the soil 1 has been defined. Now so we have to now define the load. Okay, so assign the load actually. So the data which was shown previously, that should be used. So we have for each column we have to apply the dead load and live load. Okay, so let us open this reference file for the dead load and live load. So you can see these dimensions are given here. So here also we have to see the location of the C1, C2, C3, C4 like that. So here it is C1, C2, C3 and C4 like that. So we have seen that uh, orientation or location of the columns and with naming, so we'll assign according to that. Okay, now click on this column. Okay, go to this assign, go to the load data, then point load, here dead load, and here it is dead load is 1850 kilonewton. Okay, the dimensions of column is 500 and here it is 500. Okay, click on OK. Add to existing loads, click on OK. Similarly, here in this column we have to select the apply the live load of this amount. So again select this, you can see the selection, one point selected. So click on this assign, then load data, then point load, and change this value live load. So here it is 797.6. so this thing should not be changed again because it's same dimensions. Okay, so click on OK. So likewise we have to assign the loads on each and every column. Okay, so I'm just first forwarding this part. Okay, you can do it, I hope. So this is the last load assignment, so it took long time, so it is quite a bit lengthy. So click on OK. Now you can verify each assignment. Suppose you want to verify the loads on this column. Okay, suppose let us 1 2 3 4 5 6 7 8 9 10. Okay, so let us check this column. So right click on this, click on this load. So here you can see the load, that is 5154. Okay, and um, that is where it is dead load. So 5154 and live load is 2644. Here you can see 5154.6. It is dead. Live load is 2644. So likewise you can check all the loads. Okay, and then this will be automatically determined. Okay, so nothing to be determined here, to be assigned here. Click on OK. So likewise you can check the this reinforcement assignment. So as you can see here, it is HYSD 500, so it is all right. We have to analyze this footing. So click on this, go to this run, then run analysis. So before that, it will ask you to save this file. So foundation assignment. Okay, click on save. So it is running, preparing to run analysis. So you can see the deform shape or displacement. So you can see the these guidelines. You can see the this is 4 mm, so this is -3 mm, so it has gone down. Okay, so based on this map or the legend data, you can verify the displacement in this footing. Okay, now you can go to this run analysis and design. So click on that. Okay, so now go to this display, because we have to check whether it is fine or not. So go to this show punching shear design. So click on this. So as you can see, these some of for some of the columns it is more than one, so we have to change this footing thickness. So to change that footing thickness, we have to unlock this, because it will fail in punching, so we have to change it. Okay, there is no other way. So we have to unlock this model. So go to this define, then slab properties, then click on this mat footing, then modify properties. So let us change it to 900 millimeter. Okay, so click on this OK and OK again. So then again run analysis. Again analysis and design. Here go to this display and then this. So here you can see this, for some columns it is more than one again. So again we have to change this thickness. So go to this unlock option. Change it to 1200 millimeter. Okay, so again run analysis. Here the displacements are changing, because we are changing the property of the slab, footing slab. That's why this displacement will change also, obviously. So then go to this run analysis and design. Okay, now then go to this display and this show punching shear. So here you can see for every values it is less than 1, so we can certainly say that this column or this footing will not fail in punching. Okay, so that means it can be accepted. Now you can see the detailing of this footing design. So go to this run and this run detailing. Okay, so select these three options, click on OK. So here it will show you the detailing options. Okay, so you can see the detailing of this footing from this model explorer. Okay, but before that you can see the forces in the column strips in each column strip. So for that, go to this display option, so strip forces. So here you can select the load cases either, or you can select the load combination. So you can select the load combination here. So, then moment, and then you can see the forces in layer A. So select these two values, so it will show you the okay moment, okay, for this load combination on the column strip A, okay, in these directions. Similarly, you can see the direction in B direction, so click on apply, and then you can see the shear forces in B direction, click on apply, like that. Okay, for A direction, select this, okay, click on apply. So likewise you can see the strip forces. So here you can see the slab forces also. So for load combination 1, okay, so let us see the maximum moment, so click on apply. So these are the slab forces. Then let us see the maximum shear, click on OK. So this is the maximum shear, so you can see it is in 10 to the power 3. Okay, so you can see the values here when you take your mouse cursor on any point. Okay, so likewise here at this point it is the moment is, sorry, the moment, not moment, the shear force. So there is 249.24 kilonewton per meter. Okay, so you can see this, you can see the moment and maximum shear force for load cases only for dead load, like that. Okay, so click on close, and then we can show the slab design. Okay, so let us go to that. So let us impose a minimum reinforcing, so click on apply. So here in this strip, in this layer A, this is the reinforcement detailing or reinforcement area after imposing the minimum reinforcement. Okay, in each strip you can see the reinforcement detail. Okay, then for layer B, click on apply. So here it is the reinforcement area for layer B. Okay, now you can see the crack width also from display options. So here you can see it is show crack widths. So for load combination 1, let us see, click on apply. So there are different dimensions of crack which are possible in this footing slab. These are marked on this slab as different color. Okay, you can study this, okay, to understand the crack pattern. Where are the chances, what are the chances of crack in this footing slab? Now let us go to the detailing. So click on this run and run detailing. Click on this again. We have run this previously, so this is asking run new detailing and generate drawing. Okay, run OK. Okay, then go to this model explorer and then these drawing components. So expand this. So here you can see different details. Okay, and then go to this slab view, then rebar table. uh, Sorry, so it is not showing, so let us run again. So run detailing. Okay, so again go to that option. Now it is showing. Okay, so this is showing the bar number, this is bar diameters and shape code and the cut length, total length required. Then rebar schedule it is showing, and then bill of quantities, how many quantities are required. Okay, this is shown. Okay, then individual slab view, in this go to these options. So rebar plan, so you can see the rebar plan in each in location. Okay, you can zoom this figure to see the river plan. Okay, now go to this top river plan. So this is the top river plan, this is bottom river plan. Okay, so this is section 1, this okay, for the reinforcement. Then you can see the reinforcement profile for each layer. So these are the reinforcement profile. Okay, so these things are required to execute the work in the practical side. Okay, so you have to understand this part of this result output, because this is very, very important. Okay, so thank you for watching.